first, like this part on our picture, it is mostly for our somatic fibers, and as you see here, we're having like the efferent fibers are transmitting the impulses to our like internal organs mostly. And in as you see here, we're having some kind of ganglion, right? This is like the efferent nerve, and we're having the ganglion there. So we can say that in our INS system, the efferent pathways are having preganglionic and postganglionic bodies, and mostly our cell bodies of the preganglionic neurons are located in the lateral gray columns of the spinal cord and in the motor nucleus or of the 3rd, 7th, 9th, and 10th cranial nerves. And the axons of the cell body synapse with the cell bodies of the postganglionic neurons, and they are together called the ganglia. Like the synapses area, as you see here, it is called our ganglia. So we can say that, for example, it is like the gray columns, right? Where the gray column is here, we're having like the preganglionic impulse, like the neuron, and it is junctioning with the postganglionic, which is in the black line here, and the postganglionic, it is merging with the organ system, and where the pre and postganglionic are together, we are like when they are synapsing together, we are calling it like the sympathetic ganglia, right? For example. Or paraganglia, depends or if we're talking about sympathetic or parasympathetic parasympathetic systems. The control of our autonomous nervous system is really rapid, and it is also widespread, and it takes several seconds to widespread the impulses, and also our preganglionic axon that it is merging with the postganglionic neuron in the ganglion. The one presynaptic ganglion can merge with multiple postganglionic, and that's important. And that's how they are creating our autonomic plexuses, for example, and mostly we're having our autonomic plexuses in the thorax, abdomen, all the pelvic cavity, right? Yep. So how they are working, right? How they are taking information from the organ with the afferent, and on which they are working like the efferent ones. And we're having visceral receptors, and these visceral receptors are, for example, chemoreceptors or baroreceptors or osmoreceptors that sensing different types of the pain or like chemicals, for example, and they are the ones who are taking the stimulus with the afferent fibers and also receiving like the information with the efferent fibers, right? Also, like when we're talking about the pain receptors, if you remember, I guess I did it with you guys, this kind of receptors. We won't have any kind of pain receptor like straight ahead to feel the pain in the visceral organs, right? So the visceral organ pain receptors will mostly concentrate on the lack of the oxygen or stretch or some kind of internal disbalance of the nutrients, and this is giving the visceral organs the pain. And the, like for example, if there is like extreme stretch, then we are feeling the pain of, for example, stomach, and this is called our pain for the internal structures. Okay, so now talking about the organization of our let me see if it is in here. To talk about the organization of our structures, we are having the autonomous nervous system is divided in two parts, and we are having actually three parts. We're having enteric nervous system, that it is mostly for our GI tract, because GI tract is having enteric nervous system. We're having sympathetic nervous system, and we're having parasympathetic nervous system mostly. Yeah, both of them, like sympathetic and parasympathetic. Also the enteric nervous system, they are having our pre and post preganglionic and postganglionic nerves mostly, and they are having their own synapses, let's say. Yeah, well, now I want another PPT. So see, we're having to talk about our sympathetic nervous system. We're having mostly several stuff that we should know. We're having sympathetic preganglionic neurons. We're having sympathetic ganglia, postganglionic sympathetic neurons, and these neurons are distributed to the sympathetic to all organs. And we will talk about sympathetic distribution. And we're having also the impact of the sympathetic stimulation, right? So to talk about the sympathetic ganglions, where they are located and how they are located, we're having, let's say, sympathetic division. We're having preganglionic neurons. Mostly they are located in the lateral horns of our spinal cord and T1 to L2. And they are like dividing into the ganglionic neurons, like the paired, unipaired, or the paired, but depending on the location. For example, when the impulses are coming out from the lateral gray horn of the spinal segment, from T1 to L2, they are divided into the sympathetic chain ganglions, which are paired. We can have them unilateral also, and one of the branches is going to our adrenal medulla, because if you remember and if you know, in the adrenal medulla we're having chromophrenic cells which are synthesizing our epinephrine and norepinephrine. So it needs like sympathetic and parasympathetic impulses to synthesize epinephrine and norepinephrine. And of course, we're having, judging like from the ganglion neurons where they are released, we're having the target organs and where they are working, and we're having, for example, visceral effectors, mostly for the thoracic cavity. It will be our head, body walls, and limbs, or the collateral ganglion, which are unipaired. They are transmitting the information to our stomach and abdominal cavity. And adrenal medulla, as it is synthesizing our epinephrine and norepinephrine, they are transmitting throughout the whole trunk of our epinephrine and norepinephrine to our whole parts, right? So to see a bigger overview of what we just said, it will be here, this slide, for example. And we see how from T1 to L2 were released our sympathetic fibers, right? And they are called like the efferent fibers. And mostly the lateral gray columns of our spinal cord from T1 to L third segment. Here it is mentioned L2, but like normally it will be L3 segment, send our sympathetic fibers to with the myelinated axons with the anterior roots to the white ramming communicates, and to the paravertebral sympathetic tract. So what you see here, this is our paravertebral ganglia. Like ganglia will be here, and this is our sympathetic trunk. And here we're having merging of our preganglionic and postganglionic neurons together in the sympathetic trunk. Questions still here? No questions? So what is sympathetic trunk? Yes, and there we're having paravertebral ganglia, meaning next to the vertebra, right? That's called paravertebral ganglia. Okay, so there we're having merging of our pre- and postganglionic fibers. So the gap between neurons, that like where we're having synapses, it is caused by one of the neurotransmitters, and it is called acetylcholine. And if you remember, and if you know, acetylcholine, it's our excitatory And as you see here, they are transferring to the different organs, right? It can be heart, lungs, like the stomach, etc. Some here, wait, let me see. Yeah, one of the most important here it is that our suprarenal gland, which is having like the ganglion inside mostly, and they are activating our epinephrine synthesis in the sympathetic part mostly. As you see here in different colors, we're having, for example, the pelvic splanchnic nerves C2, 3, 3, C4. They are the splanchnic nerves, and also some of the splanchnic nerves can pass through the sympathetic ganglia, and also live there like with the myelinated fiber. And we're having for these like several splanchnic nerves. We're calling that greater splanchnic nerve, lesser splanchnic nerve, and lower or least splanchnic nerves, who are getting there and mostly controlling our urine with the sympathetic nervous system, of course. So meaning that organs will have both of them, or like the splanchnic innervation and autonomous innervation too. And here it's not painted, but they are creating our plexuses, like renal plexuses for the kidneys and the bladder, from where we're having division of the splanchnic and like merging of the splanchnic and the autonomous nervous system. For this kidneys, we're having also like the celiac plexus, like here, celiac ganglion, and this is important because like we're having like the thoracic vertebral autonomous nervous system, like not from one point but also like from several locations. We are gathering the impulses and they are going to the suprarenal gland and to the kidneys. Questions regarding that? No questions? Okay. So we understood how the afferent fibers are working, right? However, regarding the afferent fibers, which are generating impulses from the organs and then they are going to the back to the spinal cord, they are afferent myelinated fibers that travel vice versa to the sympathetic ganglia, and they are not doing any kind of synapses anywhere in the sympathetic ganglia. They're just traveling straight ahead. They pass to the spinal nerve via the white rami communicates and reach the cell bodies of our posterior root ganglion, and there they are merging with the let's say the brain, and we're getting some kind of information. So we're having like gathering these kind of impulses. So for example, with the we're having afferent neuron, it is going to the sympathetic trunk. It's not merging on doing any kind of communication. With the white ramos, it is going to the colon, and here we're having the straight ahead merging with the afferent neuron, and it's coming back, and then the afferent one, it is doing our synapses. To check with, for example, our somatic nervous system, here we're having connector neuron in some cases, which is like connecting like afferent. In this case, we don't have anything like that. Okay, questions regarding that? No. To talk about the sympathetic trunk, like this was the sympathetic trunk, right? Our sympathetic trunk. Sympathetic trunks are two convoluted trunks, as you see, and they are extending the whole length of our vertebra column. And in the neck, each trunk has around 3 ganglia. In thorax, it has around 11 or 12 ganglia, and in the lumbar region, we're having around 4 or 5 ganglia, and in the pelvis again around 4 and 5 ganglia. And the ganglia, as you know the name, they are merging with the pre and postsynaptic neurons together. In the neck, the trunks lie anterior to the transverse processes of our cervical vertebra. In the throat, the heads of the ribs or lie beside the vertebral bodies. And in the abdomen, their location is mostly anterior lateral to the side of the bodies of the lumbar vertebra. In the pelvis, they are anterior to the sacrum. And below the two trunks terminate by joining together to form a single ganglion. We're calling it ganglion impar. Questions regarding the ganglion and regarding the sympathetic trunk? Here, what it is most important that you should, I guess, on the quizzes they will ask regarding the number of the ganglions we are having around each location, the neck and the trunk and the pelvis, because it's most important. Questions regarding the sympathetic nervous system? If there is no questions, then we're doing our parasympathetic part. And parasympathetic part, let me see some photos here. I don't want to miss anything. Oh, I missed this photo. So here, as you see, when we talked about the, as we see here, we're having the ganglion, right? For example, this is our sympathetic ganglion, and it is our preganglionic neuron, and we're having postganglionic neurons, right? And as you see, and as we mentioned, we are having, for example, some kind of cells. They are merging together, right? So as you see here, we merge two ganglions together. Also, we're having preganglionic modulating fibers, this, and they are also merging with our postganglionic fibers with the Siev cells, for example, and meaning that like these Siev cells can be multiple, and that's how we're merging with the different postganglionic fibers. Here, as I mentioned, acetylcholine is one of the main neurotransmitters in sympathetic nervous system, and this is like how the synapses is happening. For example, we're having preganglionic and postganglionic fiber, right? And between them, we are having some kind of space, and it is called our cleft, a ganglionic cleft. So let's see how acetylcholine is synthesized, and I will explain more easier. Yeah, for example, like this photo. Can you see, guys, it well? So see, this is one of our nerve, like preganglionic, and it is our postganglionic, right? So preganglionic, inside its axon is synthesizing, and cell body is synthesizing our acetylcholine with the acetate plus choline, and we're getting acetylcholine, and then with the receptors, it is packed in the in our vesicles like this, like here, as you see, in the vesicles, and high amount of inward of the calcium is releasing our vesicle with the acetylcholine. And acetylcholine, it is reabsorbed by the receptors. We're having nicotinic and muscarinic receptors, which are located on our synaptic ganglion, and they are reabsorbed with them, right? However, the much amount that it is synthesized, some of them it is not needed, and in the synaptic cleft, which is called like the space between the pre and postganglionic neurons, we're having synaptic cleft, and it's in the synaptic cleft we're having acetylcholine esterase, which is like degrading acetylcholine to acetate and the choline, and the choline is back again reabsorbed in our presynaptic neuron with the sodium to start synthesize of our acetylcholine one more time. And regarding the acetate, if you remember from the body system 1, our acetate, it is precursor for acetyl-CoA, and it will go some in the biochemical reactions like the Krebs cycle and etc. Right? Questions regarding this? Was it clear? Okay. Yeah. Now let's let me see another pics that we're having here. Yeah, we'll talk about like acetylcholine more in details. And yeah, now let's concentrate on like you got the what the sympathetic nervous system was, right? With the combination of the parasympathetic system, let's discuss parasympathetic system also. In parasympathetic part of our nervous system, it is mostly concentrating on our conserving and restoring the energy, while the sympathetic system is mostly fight system, fight and flight, right? It is like, for example, when you see a barking dog which is running towards you to bite you, your sympathetic system is starting to play a role and you are running away from the dog, meaning that your heart rate is becoming more and more, and you are having more and more, let's say, sweating, and your pupils are becoming more and more, and your heart is starting beating faster. However, in that case, your GI tract is fully stopped and it's not working. So, meaning the idea of the parasympathetic system, it is to release the adrenaline and start the reaction regarding the adrenaline to help you. However, parasympathetic system is doing vice versa, and you are having mostly like the restoring energy and getting you the rest. And for example, in that case, we're having the heart rate slowed and the pupils are constricted, while in the sympathetica you are having like dilated pupils, your peristalsis and glandular activity is increased, sphincter are opened, and you are having, let's say, more time for yourself to relax after the sympathetic system. Again, we're having here, so sympathetic, again there we are having like efferent and afferent nerves, and they are again working on our let me see if I'm having here, they are working on our organ systems also, and let me see if it is this one. No, it's all sympathetic. Yeah. So yeah, nuclei in default with the cranial nerves. So for example, oculomotor or the facial or the glossopharyngeal or all the vagus nerve, they are carrying the information of the parasympathetic fibers also, right? And the connector nerves cells are myelinated, and they are merging with the brain with the cranial nerves, of course. Also, like last time I showed this splanking ones, and here like they are painted together, the splanking nerves are coming also from here. We're having sacral connector nerves that are found in our gray matter of the second, third and fourth sacral segment of the spinal cord, and these ones are the ones who are coming from the lateral gray horns. And so does the sympathetic connector neurons from the thoracolumbar region, like they are having the same location. And the myelinated axon leaves the spinal cord in the anterior nerve roots of the corresponding spinal nerve, and they leave the sacral nerve and they are creating one big pelvic sacral nerve, as you see here. So they are having different origin, different level of origin. However, when they are leaving, they are creating in one big pelvic sacral nerve, and then they are going to their organs, let's say. Yeah, so all of the fibers of our cranial sacral outflow are myelinated efferent fibers, and they are preganglionic, and their synapsing is happening in the peripheral ganglia, and their ganglia are located close to the viscera of the organ. So if in the sympathetic trunk, if the sympathetic trunk was closer to our vertebra, In this case, we don't have it closer to our sympathetic area. Vice versa, the parasympathetic ganglia, as you see here, I will zoom and you will see it. See, this ganglia is not located next to the paravertebral area. It is located next to the visceral organ. For example, here and here, they are like all close together, even next to the organ, right? Even here, the the ganglia are next to the organs mostly. Yeah. Also, here in the parasympathetic areas, our neurotransmitter is acetylcholine, right? And the cranial parasympathetic ganglia are ciliary, pteroglossoparatine, submandibular, or otic, and central location of the ganglia cells are, for example, cardiac plexus or pulmonary plexus or mesenteric plexus called Auerbach, or the submucosal plexus called Meissner plexus. So, meaning what I said right now, it means that they are in the organs right ahead, right? So Auerbach and mesenteric plexus, which are enteric nervous system mostly, they are the ones in GI tract, and the pelvic splenic nerve, with the hypogastric plexus, they are merging from the hypogastric plexus. So to get the nerves in the Meissner's and the Auerbach innervation, we should have like first hypogastric plexus, and then this is divided into the plexuses. As you see here, we're having, for example, one hypogastric plexus here, for example, and it will give the innervation to the other Auerbach and Meissner's. Postganglionic parasympathetic fibers are really short, as they are non-myelinated. And why they are short? Because their synapses is happening next to the organ, so they don't need to be big, right? And ratio of the preganglionic and postganglionic fibers will be up to 1:3 or lesser, and they are much more restricted than we're having in the sympathetic part, because like the ratio of the preganglionic and postganglionic fibers in the sympathetic nervous system, it was 1:10, meaning that like sympathetica has more wider control on the involuntary structures than our parasympathetic fibers. Questions regarding this, guys? No. Now let's talk about the afferent fibers of the parasympathetic parasympatheticum. So afferents are like myelinated fibers, and they are taking information from the visceral to the our brainstem, and their location is in the sensory ganglia of our cranial nerves, or in the posterior root ganglia of our sacrospinal nerves. And central axon, they are entering the CNS, and of course they are taking part in the creation of our local reflex arches, or the past higher centers of the INS, or the hypothalamus. So the afferent components of our parasympathetic fibers, they are the same as we're having in our somatic nerves, and yeah, they are the same, and they are having the same function actually. Yeah, so mostly like autonomic afferent fibers of parasympathetic system, they are activated by the heat and touch, rather than like the oxygen or rather than stretching or the oxygen lack, because stretching and oxygen lack was for our sympathetic fibers, and parasympathetica is most concentrating on our heat or touch. So they are going to the spinal cord and brain, and they are almost going like the same direction and same way as our somatic afferent fibers. They are even located together. Questions regarding that? Okay. Now if you don't have questions, we'll discuss this. Yeah. Now let's concentrate on our autonomous plexuses. So autonomous plexus, it's when we're our viscera. Mostly thorax contains like cardiac, pulmonary, or esophageal plexuses, and in abdomen we're having like the plexus that it is associated with the aorta and its subdivisions that are named according to the areas where they are located. So we might have like celiac, we might have like the stomach plexus or like the intestine plexus, and all of them, they are having their own ganglions, and even the ganglions are named according to the aorta they are located. For example, we're having celiac plexus with the celiac ganglions, we're having superior mesentery ganglions with superior mesentery plexus, we are having inferior mesentery and aortic plexuses. So let's see a photo of this, it would be more easier for you to memorize. Like it doesn't show us really well, but like as you see here, we will have some kind of plexuses here. Let me see, like for example, they will have this kind of location, and this kind of, see, we're having, for example, this is our celiac axis, and around it we're having different nerves. For example, here we can see celiac ganglion and how these ganglions are located, like connected to each other, and also they are having out of them some kind of nerves, right? Parasympathetic and sympathetic nerves. So yeah, this is our huge, for example, abdominal INS plexus. Questions regarding that? No. Okay, if you don't have questions, then let's continue with our autonomic ganglia. Despite that we discussed it a bit, let's go more into details regarding the autonomic ganglia, and we'll talk about what are the sieve cells and etc. So autonomic ganglia, it's a site where we're having like preganglionic nerve fibers merging together, right? And as we said that we're having parasympathetic and sympathetic ganglions, and in the sympathetic trunk, which is located next to the vertebra, we're having like sympathetic one close to the vertebra and parasympathetic